Hi dears, welcome to Kerala NEET Academy one-shot series. Today we are discussing about an important chapter, electric charges or fields. This is very important chapter. This is the first chapter in our 12th channel, and this is very important because this is the basic of our electrostatics. Electrostatics theory. What is electrostatics? Electrostatics means charges at rest. We discuss about basic of electrostatics in this chapter, and next each chapter is we want to base of this electrostatic or electric charges and fields. Okay, from this we can say from the name of the chapter we can say the topics are the electric charges, fields, and its some properties. These are the main topics of this chapter, and we discuss about the electric charges and fields. Okay, first, what is electric charges? What is electric charges? What is electric charges? Charge is an intrinsic property of matter which gives rise to electric force between the various objects. That is, electric charge means it gives rise to its electrostatic force, electric force. The object which rise the electric force, that object is called electric charges. The object which can rise the electric force, that object is called electric charge. What is the SI unit of electric charge? SI unit of electric charge is Coulomb. Coulomb is the SI unit of electric charge. Okay, simple theory. That is the electric charge. Next, what are the properties of electric charges? What are the properties of electric charges? Electric charges have some property. Its first property is additive property. For some property is additive property. That is, for a system there are n number of charges Q1, Q2, Q3, Q4, Q5, etc. Qn. There are n number of charges. Then what is the total charge? Total charge is the sum of the charge. Total charge is the sum of the charge Q1 plus Q2 plus Q3 plus etc. plus Qn. That is called the additive property. That is, additive property is for a system there are total different number of charges. Then sum of each charges is called total charge in the system. That is the additive property of charge. Next property is conservative property. What is conservative property? Name will there in conservative. Conservative property is conserved. What is conserved? Charge is conserved. Charge is conserved. Conserved means constant. What is conservative property? The total charge of an isolated system is always conserved. For an isolated system conserved. Here charge is constant. Charge is conserved. Charge loss avilla. Charge is neither losses. Charge is neither created and losses. That is called a conservative property. Next one is quantization of electric charges. Quantization of electric charges means in the universe, charge of any body is integer multiple of E. Charge of any body is integer multiple of charge of one electron, that is E. That is called a quantization property. What is quantization property? For in the universe you can consider any object, charge of the object is integer multiple of E. That is for an object 2E, 3E, 5E, in the many charges are there. But 7.2E is the charge of an object. It is not possible. 1.7E is the charge of an object. It is not possible. That is not integer multiple of E. Only in the universe, charge of the object is integer multiple of E. Charge of the object is integer multiple of E. That is the quantization of the charges. But these are the different properties of charges. First one, additive property. Second one, conservative property. Third one, quantization property. But these are the properties of charges. Then, what are the method of charging a body? What are the method of charging a body? For charging a body, there are different methods. First one is charging by friction or charging by rubbing. Charging by friction or charging by rubbing. Through rubbing, here charge can be transferred from one point to another. That method is called charging by friction. By direct rubbing contact, charge can be transferred from one point to another. That is called charging by rubbing. What is charging by conduction? Charging by conduction means through direct contact, from a conductor, charge is passed to another body. But charging by rubbing is only for insulators. Charging by rubbing means in insulators, by rubbing, charge can pass from one point to another. Charging by conduction means to direct contact, charge from one body to another body. Charge from one body to another body, transferring there. So, inge charge plus positive charge through direct contact, in positive charge transferred there. That process is called charging by conduction. Then what is charging by induction? What is charging by induction? Charging by induction is here there is a charged body. Here is a charged body. This charged body is placed contact to an uncharged body. If charged body is placed contact to an uncharged body, this uncharged body in the side, uncharged body means no charge. No, uncharged body means neutral charge. That means there are equal number of positive and negative charges are become neutral. And the charge is positive charge is negative charge is. So the positive charge and negative charge is due to the positive charge here, positive charge from this side moves to this side due to repulsion. Due to the positive charge here, charge at this side moves to that side due to repulsion. So, due to attraction, opposite charge. This process is called induction. What is induction? When a charged body is placed near an uncharged body, the opposite charge will move produce at the nearer side and other charge will produce at the larger side, farther side. Farther side, other charges produces. That process is called charging by induction. So, there are three methods of charges. Charging a body, first one charging by friction, second one charging by conduction, third one charging by induction. Charging by induction. First charging by rubbing. Now already solely method of charging insulators. Insulators charging method is charging by rubbing. Charge obtained by a body, rubbing with another body is called frictional electricity. But this is in insulator. Then here I rubbed in here. So charge will move from one body to another. And that charge is called frictional. Due to that charge, electricity is called frictional electricity. Frictional electricity. So that is frictional electricity. Example: glass rod rubbed with silk. If a glass rod rubbed with silk, glass rod will get positive charge and silk will get negative charge. That means electrons move from one point to another. So positive and negative charges are obtained. Next one, comb with dry hair. Dry hair become positive charge, get positive charge and comb get negative charge. That is charging by rubbing. Already solely charging by conduction. Charge is brought to contact with an uncharged conductor. Charge flows from charged body to uncharged body. Charged body moves from uncharged body, charged body to uncharged body. Charging move pannum. If they are in contact, both contact, that is charging by conduction. That is produced for, that is method of charging conductors. Charging by conduction is used for method of charging conductors. What is charging by induction? When charged body brought to nearer to an uncharged body, not contact. What happened? Nearer end gets opposite charge and farther end gets same charge. That is called charging by induction. Charging by induction. That are the methods of charging. Okay, here this is a first important topic of the chapter. Next, this is the first important in the chapter. Question around the first important topic is this, that is Coulomb's law. What is Coulomb's law? What is Coulomb's law? Here, two charges, first one Q1, second one Q2, these are separated at a distance R. Here are two charges. First one is Q1, second one is Q2. These two charges are separated at a distance R. Two charges are separated at a distance R. Okay, then these two charges, due to two charges are placed there, there has a force is there. There has a force between two charges is there. There is a force between two charges is there. That force is called electrostatic forces. Due to two charges Q1 and Q2, separated distance R, there is a force between two charges. That force always is directly proportional to. That force between two charges is directly proportional to Q1, Q2. Product of two charges and inversely proportional to square of distance between two charges. This is called a Coulomb's law. But Coulomb's law is the force between two charges, force produced between two charges is directly proportional to product of the two charges and inversely proportional to square of distance between two charges. That is called Coulomb's law. F proportional to Q1 Q2 by R square, then F equal to K, a constant K into Q1 Q2 by R square. What is that K? K is 1 by 4 pi epsilon naught into Q1 Q2 by R square. This is the equation of force between two charges. This is called Coulomb's law. What is Coulomb's law? The electrostatic force between two stationary point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. That is F proportional to Q1 Q2 by R square. F is equal to constant, that is 1 by 4 pi epsilon naught into Q1 Q2 by R square. This is called Coulomb's law. This is called Coulomb's law. What is epsilon naught? Epsilon naught is permittivity of the medium. Epsilon naught is permittivity of medium. Epsilon is the permittivity of the medium. Epsilon is the permittivity of the medium. Epsilon naught is the permittivity of free space. Epsilon naught is the permittivity of free space. Free space permittivity is epsilon naught. Epsilon is the permittivity of medium. Permittivity of medium is epsilon. Okay. What is 1 by 4 pi epsilon naught? 1 by 4 pi epsilon naught is a constant value. 1 by 4 pi epsilon naught is a constant value. 1 by 4 pi epsilon naught is 9 into 10 power 9. 9 into 10 power 9. What is a unit? Unit here Newton. Mele poyal meter square. Key vannal Coulomb square. So 9 into 10 raised to 9 Newton meter square per Coulomb square. 9 into 10 raised to 9 Newton meter per Coulomb square. What is permittivity epsilon naught? Permittivity of free space epsilon naught is equal to 8.835. 8.835 into 10 power minus 12. 8.835 into 10 power minus 12. 10 power minus 12 minus 12. Here reciprocal, because 1 by 4 pi epsilon naught, the reciprocal is epsilon naught. So that is in the reciprocal, that is Coulomb square per Newton meter square. Coulomb square per Newton meter square. That is the value of epsilon naught and 1 by 4 pi epsilon naught. So what is Coulomb's law? That is force F is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square. 1 by 4 pi epsilon naught is 9 into 10 power 9 in Newton meter square per Coulomb square. Epsilon naught is 8.835 into 10 raised to minus 2 Newton meter Coulomb square per Newton meter square. That is Coulomb's law. Next is, what is superposition principle? What is superposition principle? If there are number of charges q1, q2, q3, etc., qn around a charge q, then total charge acting on the q is the vector sum of the force on the charge q due to individual charges. But total charge, total force acting on q, total force acting on q is the, q is there, q1 irukku, q2, q3, q4, etc., qn. Then what is the total force? Force due to q1, force due to q2, force due to q3, force due to q4. All forces in the vector sum is total force. Vector sum of all forces is total force. That is called superposition principle. Okay. Superposition principle states that vector sum of the all forces due to two charges gives total force. Okay. Then how find the direction of force? How find the direction of force? So q1 inge irukku, q2 inge irukku. If they are attraction, that is direction of q1 is on the direction, q2 is in the direction. If they are repulsion, they are in opposite direction. Okay, due to q1 force, due to q1 charge, what is the force in the ketal? Direction of force is on the direction if they are attraction. Due to q1 charge, what is the force? Force produced in q1 charge in the ketal. If it is repulsion, that is away from this. That is a method of finding direction. But attraction in the direction, repulsion in the direction. But attraction in the direction. So q1 charge mention paniyal on the direction mark pannam. In q1 charge repulsion mention paniyal in the direction mark pannam. Similarly q2 charge also. Attraction in the direction mark pannam, repulsion in the direction. Okay, but that is the magnitude and the direction of force. But total force is the vector sum of all forces. That is called a superposition principle. Then next Coulomb's law we discuss about electrostatic force. Next, we want to understand what is electric field. What is electric field? Electric field in Julial, it is a space around electric charge. Electric charge due to this charge, there are surrounding spaces has electrostatic forces. Due to electric charge, surrounding spaces has electrostatic forces. It is a space around the electric charge wherein electrostatic force is experienced by another charge. It is a space around the electric charge wherein electrostatic force is experienced. In the surroundings, electrostatic force experienced due to another charge, that space is called electric field. Electric field intensity at a point is the force experienced by unit positive charge placed at a point. At a point, unit positive charge produces a force that is called electric field intensity. Electric field intensity is force. That force produces a unit positive charge. Unit positive charge produced by the force. That is called charge is 1 unit. That 1 unit angle, that force is called electric field. So electric field is force per charge, unit positive charge. So force per charge, that is electric field. What is electric field? Electric field is the force produced by unit positive charge. Then how write the equation of electric field? How write the equation of electric field? Electric field is equal to 1 by 4 pi epsilon naught into one charge q1, that is q. Another charge is unit charge, that is unit charge. So that is 1 now divided by r square. This is the electric field. So electric field is equal to 1 by 4 pi epsilon naught, that is kq divided by r square. That is electric field is equal to F by q, or you can simply write electrostatic force F is equal to QE. Simply write electrostatic force F is equal to QE. For what is electric field? Electric field is only a space around electrostatic force is produced. it simply electric field intensity that is the force produced by due to unit positive charge. Force produced due to unit positive charge is called electric field. Electric field is equal to K 1 by 4 pi epsilon naught into Q by R square. Q divided by R square, that is electric field. Next, charge placed in an electric field. Charge placed in an electric field. Here, a charge is placed in an electric field. What happens? This is an electric field. A charge is placed here. A charge is placed in an electric field. What happened? What is the force? Already electric field is equal to F by Q. Then what is force? F is equal to QE. Force F is equal to QE. Force F is equal to QE. Then what is the acceleration? Force F is equal to MA. Force F is equal to MA. So MA is equal to QE. So A is equal to QE by M. A is equal to QE by M. So acceleration is equal to QE by M. About electric field is applied. Force F is equal to QE. Acceleration is equal to QE by M. What is velocity? How find velocity? V is equal to U plus AT. V is equal to U plus AT. Here, initially, if there is no electric field, velocity is 0. Initially, if there is no electric field, velocity is 0. So you can write V is equal to U plus AT. Initially, velocity is 0. So velocity is equal to AT. What is A? QE by M. A is QE by M into T. So velocity is QE by M into T. Okay, so force is QE, acceleration QE by M, velocity QE by M into T. Next one, momentum. What is momentum? Momentum is mass into velocity. Mass into velocity, mass, M cancel. Balance QET. Balance QET. So momentum is equal to mass into velocity, that is QET. Displacement Displacement S is equal to ut plus half at square. Displacement case initial velocity 0 below before applying electric field u is equal to 0. So that becomes 0. So equation become half a. What is a? A QE by m into t square. Answer QE. Displacement is half QET square by m. Displacement is equal to half QET square by m. Last, kinetic energy. Kinetic energy is half mv square substitute. Half mv square. In the square, if you take the square, m or m cancel, balance q square, e square, t square. Key 2 half into 2. Key m. Q square, e square, 2 square by 2m. Or t square by 2m. Or otherwise, force into displacement is substitute. Work is converted to kinetic energy. So what is the work? Work is equal to force into displacement, that is QE into this value. Answer is again. So these are the values, different quantities when charges are placed at electric field. Charges are placed at electric field. Force, acceleration, momentum, displacement, kinetic energy. In the values allam theriyanam. Okay, simple. Okay, next. What is electric field lines? What is electric field lines? What is electric field lines? The path along which unit positive charge, or unit positive charge, move panno, that path is called electric field lines. Inge positive charge that is traveling like this. This is called electric field lines. Inga pathal theriyum. What is the direction of electric field lines? Electric field lines are moves away from positive charge. Okay, electric field lines are moves away from positive charge. Electric field lines are moves into negative charge. Electric field lines are moves away from positive charge to negative charge. So electric field lines in a path is away from positive charge into negative charge. That is the path of electric field lines. Then what are the properties of electric field lines? Electric field lines are starts at a positive charge and end at a negative charge. Electric field lines two charges, positive and negative, that starts from positive charge and reach at a negative charge. That is, electric field lines are starts from positive charge and ends at a negative charge. For an isolated single charge, electric field line starts or end at infinity. Because isolated single charge means if it is positive charge only, it starts from positive charge, end at infinity. If it is negative charge only, it's end at negative charge and starts at infinity. Okay, about this, for an isolated positive charge or negative charge, it starts or end at infinity. Positive charge end at infinity. If it is negative charge, starts at infinity. Okay, about always starts from positive to negative. Next, in a charge-free region, electric field lines have no break or they are continuous. If there is charge-free region, inge charge illa, charge regional they will stop. Other regional they are continuously moving. Other regional they are continuously moving. At a charged region it does not continuously moving. Anga will stop out. At a charged region that will stop there. At a charge free region they are continuous. They are continuous. Two electric field lines never intersect each other. Two electric field lines never intersect each other. And the reason, next is electric field lines. But two electric field lines are there. Two electric field lines are there. If there is two electric field lines, these electric field lines in the tangent drop. If you draw the tangent at any point on electric field line, if you draw the tangent at any point on electric field line, that gives direction of electric field. If you draw the tangent at any point on the electric field lines, gives a direction of electric field. Tangent drawn to the electric field lines at any point gives the direction of electric field. I draw an electric field line, that is a tangent. Next, I draw electric field line, this is the tangent. At a particular point, two tangents. At a particular point, there are two tangents. That means two directions. At a particular point, this electric field travels in another direction, this electric field travels in the direction. It is not possible. Because at a particular point, they only, one object can only move, electric field can only move at a single direction. Two direction traveling is not possible. So, electric field lines never intersect each other. If they intersect each other, there are two directions. That is not possible. So, two electric field lines never intersect each other. Point. Uniform electric field lines are parallel. If there is no uniform electric field is always represented using parallel lines. Uniform electric field lines are parallel. The number density of electric field lines at a given at a point gives a strength of the electric field. Number density of electric field line at a point. Electric field lines. Number density electric field lines per unit area. Or a particular unit area, how many number of electric field lines are there? That is number density. Number density of electric field lines gives intensity. Or particular regional, how many electric field lines? That is the number density. Number density of electric field lines gives intensity of electric field. That gives intensity of electric field. Okay, these are the important points of electric field lines. Okay, next. What is electric dipole? What is electric dipole? Electric dipole is simple when two equal and opposite charges. Inge ஒரு charge இருக்கு plus q, இங்க ஒரு charge இருக்கு minus q. They are separated by a distance. They are separated by a distance. I consider that distance is 2a. Okay, two equal and opposite charges separated by a distance is called a dipole. What is dipole? What is electric dipole? Two equal and opposite charges separated by a distance is called a electric dipole. Electric dipole moment is defined as the product of magnitude of one of the charge. Any one of the charge, that is Q, into product into distance between two charges, that is 2a. So that gives dipole moment P. That gives dipole moment P. So what is dipole moment P? What is dipole moment P? Dipole moment is the product of one of the charge and distance between two charges. That is called a dipole moment. What is dipole? What is electric dipole? Two equal and opposite charges separated by a distance is called a electric dipole. What is electric dipole moment? Product of one of the charge and distance between two charges is called a electric dipole moment. The electric dipole moment is scalar or vector. Electric dipole moment is a vector quantity. Electric dipole moment is a vector quantity. What is the direction of electric dipole moment? Direction of electric dipole moment is always from negative to positive. Direction of electric dipole moment is always from negative to positive. Very important. Very important. What is electric dipole? Two equal and opposite charges separated at a distance. Electric dipole moment is charge into distance. It is a vector quantity. Direction is from negative to positive. That is the direction of dipole moment. Then we want to understand electric dipole moment at a axial line of electric dipole. And also we want to understand electric dipole moment at a equatorial line of electric dipole. Electric dipole moment at a axial line. Inga listen. Electric dipole moment at a axial line. Simple. Here. This is two charges plus Q minus Q. Two charges are there plus Q and minus Q. Okay, here this is a dipole. Two charges means dipole. This is separated at a distance 2a. These two charges are separated at a distance 2a. Okay, then what is axial line? Axial line this is its axis. Angular line, that is axial line. That point is P. Point at the axial line is P. From center, distance to point P is R. From center, distance to point P is R. Okay, well, plus Q minus Q, separated at a distance 2a. Point P is at a distance R. Okay, then what is the electric field produced at the point P? What are the electric field produced at the point P? Due to plus Q charge, there is an electric field. Due to minus Q charge, there is an electric field at the point P. What is the direction of electric field? Always electric field is at axial line. Electric field towards negative, away from positive. Axial line towards negative enter out, away from positive leave out. So towards negative, away from positive. So this is E minus Q. This is E plus Q, because at a axial line, electric field direction is away from positive towards negative. So this is the electric field E plus Q and E minus Q. Understand the direction. How consider the direction? Understand how take the direction. That is important for questions, solving questions also. Okay, here E minus Q, E plus Q. What is the net electric field? Net electric field is E plus Q plus E minus Q, but they are in opposite direction. One ange, one inge. So we want to subtract that. So net electric field is large minus small. Net electric field is large minus small. What is large? E plus Q. What is E plus Q? E plus Q is equal to K into Q by plus Q. Then from point P plus Q India. Plus Q India. What is the distance? Distance is R plus A. Distance is R plus A the whole square. From the point P, R plus inga vare R, inga vare A. This is E plus Q. What is E minus Q? E minus Q is equal to K into Q by R minus A the whole square. Okay, but K into Q by R plus A the whole square and K into Q by R minus A the whole square are the electric field. Then you can find net electric field. E net is equal to E plus Q. Which is greater? Plus Q or minus Q? Denominator kammi answer greater. Inge denominator kammi. Inge denominator kammi. So answer greater angeya. So E minus Q minus E plus Q. E minus Q minus E plus Q. Okay, if you subtract paniyal, you will get answer is K into 2PR. K into 2PR divided by K into 2PR divided by R square minus A square the whole square. R square minus A square the whole square. For K into 2PR divided by R square minus A square the whole square is electric field. This is the electric field at the axial line. At the axial line, electric field is equal to, either just understand how take the direction, plus Q angle, again away from plus Q, minus Q angle inge, net is equal to large minus small. That is E minus Q minus E plus Q, because both are in opposite direction. Then solve pannumbol you will get electric field E is equal to 2PR divided by R square minus A square the whole square. Then this is the electric field due to a dipole. Then if this dipole is very short, short dipole A becomes very small. A becomes very small. So they can neglect that. We can neglect the A. If you neglect the A, this become R power 4, R raised to 4 and R cancel. Then electric field E is equal to K into 2P by R cube. Electric field E is equal to K into 2P by R cube. What is the direction? Direction of electric field is large minus small is the magnitude. Direction is large in the direction. Direction of large is E minus Q in the direction. Okay, in the direction of electric field. But electric field direction is in the direction. So electric field direction and dipole moment is always minus to plus R. Negative to positive. That is also same direction. So dipole moment and electric field are same direction. Are same direction in the case of axial line. At the axial line, electric field and dipole moment are in same direction. Okay, but this is axial line. At the axial line, electric field E is equal to 1 by K means 1 by 4 pi epsilon naught into 2P R divided by R square minus A square the whole raised to 2. Electric field E is equal to K into 2P divided by, if A is very small, A becomes 0, that becomes R cube. So P and electric field, dipole moment and electric field are in same direction. Okay, but this is electric field at axial line. Understand this by heart, these two equation. This is for large dipole, for short dipole, this is the equation. And also understand electric field and dipole moment are same direction in the case of axial line. Okay. Next, at equatorial line. At equatorial line, what is electric field? Equatorial lines means this is minus Q, this is plus Q. Equatorial lines means this perpendicular line. At the perpendicular line, a point P is considered. We want to find electric field. Here at a point P, this is at a distance, at a particular distance. This is 2A, total 2A. So this is A. This is at a distance R. This from center, point P is at a distance R. Okay. Then at a point P and this minus Q charge, electric field is always therium, very very important. Negative charge is there, so electric field is towards negative charge. Ingayana E minus Q. Okay, inga positive charge. Here is point P. From positive charge, electric field is away from positive charge. Ingayana E plus Q. Okay, about towards E minus Q, always electric field is towards negative charge and always electric field is away from positive charge. Then what is the resultant? Resultant is here. Ingayana resultant electric field. Resultant electric field is here. Okay, here understand the direction. E minus Q, electric field due to negative charge is in the direction. Electric field due to positive charge is on the direction. Resultant is here. Then what is the electric field, net electric field, total electric field at a equatorial line? Total electric field at equatorial line is equal to K into P divided by K into P divided by here K into P divided by A square. Here we consider distance is R, so R square minus R square plus A square the whole power 3 by 2. R square plus A square the whole power 3 by 2. R square plus A square the whole power 3 by 2. This is the electric field at the equatorial line. At the equatorial line, electric field is equal to K into P by R square plus A square the whole power 3 by 2. Here, for small dipole, A is 0. For small dipole, A is 0. So, R square is there, 2 cancel, balance, it becomes R cube. K into A becomes 0, balance is R square the whole power 3 by 2, 2 cancel, so P divided by R cube. So, electric field for short dipole is 1 by 4 pi epsilon naught, that is K into P by R cube. Electric field general equation is K into P by R square plus A square the whole power 3 by 2 for equatorial line. Okay, here one more point. Here what is the direction of net electric field in the direction? What is the direction of dipole moment? Dipole moment is always from negative to positive. Dipole moment is always from negative to positive. Electric field is in the direction. That means electric field and dipole moment are opposite direction. At equatorial line, electric field and dipole moment are opposite direction. At axial line, electric field and dipole moment are same direction. So, these are the electric field at axial line and equatorial line. Okay. Next topic is electric flux. What is electric flux? Electric flux is defined as a total number of electric field lines passing normally through a surface. For a surface, in the surface is perpendicular, that is normal to surface, how many electric field lines are passes, that is called electric flux. Electric flux is the total number of electric field lines passing perpendicular to the surface, that is called electric flux. Consider this surface. Consider this surface. Here, electric field lines are in this horizontal direction. Electric field lines are in horizontal direction. In the surface, this is the direction of electric field lines. Okay, this is the direction of electric field lines. Here, consider a small portion here. Its area of cross section is ds. Okay, consider a small portion here. Its area of cross section is ds. Area of cross section is ds. Okay, its area of cross section is ds at an angle theta. That means electric field and area vector makes an angle theta. Electric field on the direction, area vector in the direction. But electric field and area vector makes an angle theta here. Electric field and area vector makes an angle theta here. Then what is electric flux? Electric flux is that is electric total number of electric field lines. Total number of electric field lines എന്ന് ചൊല്ലിയാൽ total number of electric field lines എന്ന് ചൊല്ലിയാൽ നമുക്കറിയാം for a particular area number of electric field line is E. Number density of electric field lines gives intensity of electric field. Number density of electric field line is intensity. So for a particular area electric field line, total number of electric field line is E. Then total area that is A. E into A. Total area that is E into A. So electric flux phi is equal to E into A എന്ന് കിടക്കും. If area vector and electric field are same direction. എല്ലാ ഇലക്ട്രിക് ഫീൽഡ് ലൈൻസും പാസിംഗ് പെർപെൻഡിക്കുലർ ടു സർഫസ്, then ഒരു യൂണിറ്റ് ഏരിയയിലെ ഇലക്ട്രിക് ഫീൽഡ് ലൈൻ ഈസ് ഇ, then ടോട്ടൽ ഏരിയ ഇ ഇൻറ്റു എ. ബട്ട് ഇഫ് ദേ മേക്ക് സം ആംഗിൾസ് இந்த மாதிரி ഇലക്ട്രിക് ഫീൽഡ് ലൈൻസ് അങ്ങിരിക്കുന്നു, ഡി എസ് ഇങ്ങിരിക്കുന്നു. ഇഫ് മേക്ക് സം ആംഗിൾ then அங்க கொஞ்சம் ப்ராப்ளம் இருக்கு. So how find the electric flux? How find the electric flux? If they make some angle, then how find the electric flux? சும்மா சொல்லியால் here electric field lines make some angle. Electric field lines make some angle. So you want to consider its perpendicular on the direction of component. Direction of area vector in the direction component of electric field lines in the direction of area vector. അല്ലെങ്കിൽ component of electric field lines, normal component of electric field lines in the direction of area vector. Okay, so E ഇങ്ങനെയാണെങ്കിൽ if this angle is theta, this is E cos theta. This component is E cos theta. This component is E cos theta. So what is phi? Phi is equal to E cos theta into, if its area is S, then you can write E cos theta into S. That is ES cos theta or E dot S. E dot S. Phi is equal to ES cos theta or E dot S. If you consider small surface area, then small flux is equal to d phi. Small surface area consider paniya small flux d phi, that is integral E dot ds. If you consider small surface area, small flux angirikkum, that is d phi, is equal to integral E dot ds. Then total flux phi is equal to small flux is equal to E dot ds, then total flux phi is equal to integral E dot dx. But this is the equation to find net electric flux. Net electric flux is equal to integral E dot ds. Okay, but what is electric flux? Electric flux is the total number of electric field lines passing perpendicular to surface. If this is area, this is electric field lines, it is in perpendicular. If the condition is actually they are perpendicular, chumma you can say E into A. If they are at some angle, then E into S cos theta, that is E dot S. And if you consider small area ds, then electric flux is d phi. For finding total value, integrate paniya podum. So net electric flux is equal to this closed integral, surface integral of E dot ds. But net electric flux is integral E dot ds. This flux is this closed round symbol represent for a closed surface. For a closed surface represent round symbol. So net electric flux is equal to integral E dot ds. Okay. Next, we want to understand some charge densities. What are the different charge densities? First one, linear charge densities. What is linear charge density? Linear charge density is charge per unit length. Charge in unit length is called linear charge density. Charge coulomb per unit length meter. But coulomb per meter is the SI unit. What is the surface charge density? Charge per unit area. Charge per unit area is called surface charge density. It's SI unit, coulomb per meter square. Next one is volume charge density. Rho. Next one is volume charge density, rho. What is volume charge density? It is charge per unit volume. Charge per unit volume is called volume charge density. Its SI unit is coulomb per meter cube. Okay. Well, different charge densities are this surface charge density, the linear charge density and volume charge density. Name il thanne irukku charge per unit volume, total charge. But here is for a unit volume, how many charges are there? That is volume charge density. The next very important topic is Gauss's theorem. Important topic is Gauss's theorem. What is Gauss's theorem? What is Gauss's theorem? Total electric flux over a closed surface enclosing a charge is equal to. Here, this is a charge Q. We want to find total electric flux over a closed surface. I consider a closed surface. We want to find electric flux over this closed surface due to this charge Q. What is the value? That is always is equal to total electric flux over a closed surface is equal to 1 by epsilon naught times total charge enclosed in the surface. 1 by epsilon naught times total charge enclosed inside the surface into the surface, that is called Gauss's theorem. That is total electric flux over a closed surface enclosing a charge. ഒരു ചാർജിനെ എൻക്ലോസ് ചെയ്യുന്ന ക്ലോസ്ഡ് സർഫസിലെ ടോട്ടൽ ഇലക്ട്രിക് ഫ്ലക്സ് ഈസ് ഈക്വൽ ടു 1 by epsilon naught times net charge enclosed. ഇங்கே enclosed பண்ணிരിക്കുന്ന total charge into 1 by epsilon naught times are always electric flux. അപ്പോൾ electric flux നമുക്ക് തരും electric fluxന്റെ equation integral E dot ds ആണ്. ഈ integral E dot ds is obtained from 1 by epsilon naught into ഇങ്ക how many charges are there? ഇങ്ക 0 charge എങ്കിൽ ആൻസർ ഇങ്ക 0 ആവും. electric flux 0. ഇങ്ക 0 charge എങ്കിൽ electric flux 0. ഇങ്ക how many charges are there? അത് multiply ചെയ്താൽ you will get electric flux. So total electric flux is equal to integral E dot ds into E dot ds is equal to 1 by epsilon naught times net charge. That is called Gauss's theorem. Okay. Then we want to study some applications of Gauss's theorem. We want to study some applications of Gauss's theorem. Here, consider first application is electric field due to a spherical shell. Here there is a spherical shell. Spherical shell, here some positive charges are distributed there. Positive charges are distributed there in the spherical shell. Okay, but spherical shell എന്ന് ചൊല്ലിയാൽ that is hollow sphere. Spherical shell എന്ന് ചൊല്ലിയാൽ hollow sphere. Hollow sphere il always charges are distributed at a surface. But solid sphere il charge may distributed at the surface or inside all over the sphere. That has two conditions irukku. Okay, but hollow sphere il always charge has distributed about the surface. Okay, എന്നാൽ solid conducting sphere എന്ന് ചൊല്ലിയാൽ solid conducting sphere എന്ന് ചൊല്ലിയാലോ solid conducting sphere എന്ന് ചൊല്ലിയാൽ ഇങ്ങനെയുള്ള ചാർജ് ഇങ്ങനെ if you put a charge then what happen? It is conducting. So this charge will repel and moves into the surface. Same concept. Solid conducting sphere എന്ന് ചൊല്ലിയാൽ all charge repel into surface. Appo same concept that is charge are distributed at the surface. Okay, so hollow sphere or shell or solid conducting sphere both are same concept. But this is a solid sphere, hollow sphere or spherical shell. We want to find electric field. For this is a spherical shell of positive charge, we want to find electric flux at a point P. ഇങ്ങനെയുള്ള ഈ പോയിന്റിൽ we want to find electric flux at a point P. Okay. For finding electric flux at a point P, I consider a surface. Here first I want to find electric flux outside the surface. First I want to find out electric flux outside the surface. Here first I want to find electric flux outside the surface. Okay, here electric flux outside the surface എന്ന് ചൊല്ലിയാൽ ഇങ്ങ വരും. outside the surface is here. Okay. Here inside the radius is capital R. Outside radius is small r. Inside radius is capital R and outside radius is small r. Okay. This considering surface is called a Gaussian surface. This surface is called a Gaussian surface. For finding electric flux by using Gauss's theorem, I consider a surface outside the shell. That surface is called a Gaussian surface. Okay. Gauss's theorem apply pannan, there should have a surface. That surface is called a Gaussian surface. I consider the Gaussian surface outside the given shell. Then what is Gauss's theorem? What is Gauss's theorem? Gauss's theorem sollunnenda integral E dot ds, that is net electric flux, total electric flux is equal to Q by epsilon naught. This is called Gauss's theorem. Integral E dot ds is equal to Q by epsilon naught. That is called Gauss's theorem. In the case, what is the direction of electric field? This is positive charge. Positive charge always electric field is away from positive charge. Direction of electric field is always away from positive charge. Electric field is always away from positive charge. Surface area, what is the direction of surface area? Direction of surface area is always perpendicular to surface. This is surface, perpendicular to surface. Okay, electric field away from positive charge, surface area perpendicular to surface. That is, both are same direction. This is sphere, away from positive charge, perpendicular to surface. Both are same direction. Same direction, angle between E and ds is 0. Angle between E and ds is 0. That is cos E dot ds become E ds cos 0. Cos 0 is 1. So you can write integral. You can write here integral E dot ds, that is E ds cos 0. Cos 0 1. So E ds, that is equal to Q by epsilon naught. Integral E ds is equal to Q by epsilon naught. Okay. Then here E, electric field, is a constant there. Then what is total ds? Total ds and total surface area. Total surface area of the Gaussian surface. Gaussian surface in a surface area. Gaussian surface in a surface area is surface area of sphere, that is 4 pi r square. Surface area of sphere is 4 pi r square into Q by epsilon naught. ഇതിന്റെ കീഴെ വന്നാൽ ഇലക്ട്രിക് ഫീൽഡ് E is equal to 4 pi ഇങ്ങ വരും 1 by 4 pi epsilon naught into Q by r square. 1 by 4 pi epsilon naught into Q by r square എന്ന് കിടക്കും. So this is a spherical shell. What is the electric field outside the surface എന്ന് കേട്ടാൽ that is simply 1 by 4 pi epsilon naught into Q by r square only. 1 by 4 pi epsilon naught into Q by r square only. If you find the answer in terms of surface charge density, if you want to find the answer in terms of surface charge density Q, put Q is equal to, inga than Q substitute panna. Inga thanne substitute panna. Inga thanne Q substitute panna. Inga substitute panna. Surface charge density. Namakku theriyum. Surface charge density is charge per unit area. Q divided by area is surface charge density sigma. Then what is Q? Q is equal to sigma A. Charge engaya is small sphere la. Charge equal to small sphere la charge. So sigma into small sphere la area consider panda, because charge is only for small sphere. So you want to consider small sphere area, that is 4 pi small area, radius is capital R square. So sigma into 4 pi R square. I think a substitute panna. So E is equal to E into 4 pi into small r square is equal to Q is sigma into 4 pi into capital R square divided by epsilon naught. 4 pi cancel. E is equal to sigma r square by epsilon naught r square. So electric field due to spherical shell outside the shell is equal to sigma r square by epsilon r square. Electric field due to spherical shell outside the shell is equal to sigma r square by epsilon r square. This is for outside the shell. For outside the shell, sigma r square by epsilon naught r square is the answer. Then what is the at surface? At surface in cholumbol, this small r kammiyayi small r become capital R. Small r become capital R. So at surface electric field E is equal to, this become capital R cancel, that is sigma by epsilon naught. At surface electric field is equal to sigma by epsilon naught, or inge capital R, small r become capital R, that is 1 by 4 pi epsilon naught into Q by capital R square. Electric field is equal to 1 by 4 pi epsilon naught into Q by capital R square. Electric field is equal to 1 by 4 pi epsilon naught into Q by capital R square. Q by capital R square. Okay, Q by capital R square. But that is the electric field at the surface. If you consider electric field inside the surface, there is no charge. Outside the surface, charge. Inside the surface, net charge enclosed is 0. Because charge is only at the surface of the spherical shell. Inside consider panniyal, already Gauss's theorem solli enda, net charge enclosed in the surface. Net charge enclosed in the surface is 0. Net charge enclosed in the surface is 0. So Q is equal to 0. Q 0 angle, this electric flux is equal to 0. So inside the surface, electric flux is 0. Okay, so outside the surface, electric flux is equal to 1 by 4 pi epsilon naught into Q by R square, or electric flux or electric field is equal to sigma R square by epsilon naught R square. At the surface, on the surface, electric field is sigma by epsilon naught, or 1 by 4 pi epsilon naught into Q by R square. Inside the surface, there is no charge, so electric field is equal to 0. So electric field inside the surface is equal to 0. From this, we can draw a graph representing electric field and distance. We can draw a graph representing electric field and distance. E and R. E and R. Okay. Here. Inside on R kammiya. R is less than surface capital R. At a surface radius is capital R. Surface radius that is capital R. Small r is less than capital R when at inside. About in the region, this region is inside. This region is inside. Inside electric field is 0. Inside electric field is 0. At inside electric field is 0. And at R electric field become a large value. And at the R electric field become a large value. R electric field becomes a large value. Because what is the value of electric field? At the R electric field is at the R electric field is sigma by epsilon naught, or 1 by 4 pi epsilon naught into Q by R square. Then outside the surface electric field is 1 by 4 pi epsilon naught into Q by small r square, that is inversely proportional to R square. Outside the surface electric field is inversely proportional to R square, that is R increases, electric field decreases. Sigma constant, epsilon naught constant, capital R surface radius of this sphere, that is constant. But small r outside any points, small r is any point outside the surface, that is variable. So R increases, electric field decreases. R increases, electric field decreases outside the surface. But this is the graph representing electric field for a spherical shell. This is a graph representing electric field for a spherical shell. This is outside. Okay. But for a spherical shell, graph representing electric field and distance is like this. Okay. And we want to study about solid sphere also. Solid conducting sphere. Solid conducting sphere is here. This is a solid sphere. But if you put a charge in the sphere, what happened? The positive charges are distributed. Negative charge distribute. But if it is a conducting sphere, that is moves at the surface. Due to conduction, that will move into the surface, and due to repulsion, that will move into the surface. But it is non-conducting sphere, but that is not conducting. So this is a non-conducting solid sphere. This is a non-conducting solid sphere. Here, what is the electric field outside the surface? Same method, you can find the electric field. Same answer. Electric field E is equal to, electric field E outside the surface is equal to, electric field E outside the surface is equal to K 1 by 4 pi epsilon naught into Q. What is a charge? Total charge Q divided by capital small r square. That is at a distance r. That is at a distance r. That is small r square. Okay. The electric field outside the spherical surface is equal to K into Q by r square. That is 1 by 4 pi epsilon naught into Q by r square. Electric field on the surface. Electric field on the surface is equal to 1 by 4 pi epsilon naught into. This r become capital R. R become capital R. So electric field is equal to Q divided by capital R square. No change because charge enclosed at the surface same amount. Outside the surface, on the surface. On the surface, outside the surface, enclosed charge in the amount same. But inside the surface is the problem. Inside the surface is the problem. If we consider inside the surface like Gaussian surface, inside and content charge. With respect to surface, a charge in change. Okay. So, inside the surface, a charge that is R. If R is at a distance inside the surface of the non-conducting spherical solid sphere, then electric field is obtained by the equation 1 by 4 pi epsilon naught into Q by capital R cube into small r. This is the equation to find electric field inside the solid sphere. Okay, same method as Gauss's theorem. The same method answer. So you only want to understand these equations. Only want to understand this equation. First, outside the spherical, outside the solid sphere, electric field is equal to 1 by 4 pi epsilon naught into Q by R square. On the surface, 1 by 4 pi epsilon naught into Q by capital R square. But inside the surface, 1 by 4 pi epsilon naught into Q by R cube into small r square. This is the electric field inside the surface. Then, how draw the graph? How draw the graph for solid sphere? How draw the graph for a solid sphere? Here, this is electric field E. This is R. First, inside. Inside is 1 by 4 pi epsilon naught is a constant. Q charge of the conductor is a constant. R radius of the sphere is a constant. Only change is small r. Small r enga distance. Inga nearest point any distance. So small r is a variable. So inside the shell, this is inside, this is on the surface, this is outside. Inside the surface, electric field is directly proportional to R. Inside the surface, electric field is direct. These are constant. So inside the surface, electric field is directly proportional to R and reaches at capital R. Inside the surface, electric field is directly proportional to R. And after R, that means outside the surface. After R means outside the surface, that is electric field is inversely proportional to R square. electric field is inversely proportional to R square. After R, electric field is inversely proportional to R square. This is directly proportional to R. Electric field directly proportional to R. Here electric field inversely proportional to R square. This is inside, this is outside. At R will reach maximum, then that is inversely proportional to R square. Okay, but this is the electric field inside, outside and the surface of a solid sphere. Okay, next we want to study the next application of Gauss's theorem, that is electric field due to infinitely long conductor. Electric field due to infinitely long conductor. Consider this infinitely long conductor of any charge. I consider here positive charge. I want to find electric field due to this infinitely charge. For finding this electric field due to this conductor, in the conductor I find out one, I consider a Gaussian surface. Which surface? I consider here a cylindrical Gaussian surface. I consider here a cylindrical Gaussian surface. Cylindrical Gaussian surface is considered here. Okay, but this is the infinitely long conductor with a positive charge. I consider a cylindrical Gaussian surface. In this surface, here has a surface. Gaussian surface, cylindrical surface, or curved surface, base surfaces. Curved surfaces, base surfaces. Here, curved surface, this is the direction of area vector. Because curved surface is perpendicular. Always area vector is perpendicular to surface. This base surface that perpendicular, that is the direction of area vector. This is the direction of area vector, this is the direction of area vector. Always area vector is perpendicular to surface. Okay, then this is here is positive charge. Electric field is always moves away from positive charge. Electric field is always moves away from positive charge. So direction of electric field is on the direction. So this case, electric field and ds are same direction. In this case, electric field and this ds are 90-degree angle. So what is the net electric flux? Net electric flux is integral E dot ds due to curved surface plus integral E dot ds due to base surfaces, that is equal to q by epsilon naught. But E dot ds at a base surface, angle between E and ds is E always on the direction, ds mele, angle between E and ds is 90 degree, cos 90 is 0, cos 90 is 0. So EDS cos 90, EDS cos 90 is 0, EDS cos 90 is 0. So base surface electric flux is 0. Then there is only curved surface, that is EDS. What is the angle? Electric field on the direction, ds on the direction, angle between them 0 degree, cos 0, 1. So integral EDS is equal to q by epsilon naught. Integral EDS is equal to q by epsilon naught. Then what is integral EDS? Integral EDS, here E is constant, take outside. Surface, integral ds, which surface? Curved surface. Curved surface area of cylinder. Curved surface area of cylinder is pi RL. Length is L. So curved surface area is, R is radius. So curved surface area of cylinder is pi RL. Pi RL is the curved surface area. So E constant outside, integral ds is the total surface area of that curved surface, that is pi RL. That is equal to Q. What is Q? Q is charge. What is charge density? Linear charge density. Length area. So consider linear charge density. Linear charge density lambda is equal to Q by L. Then charge density Q is equal to lambda L. Charge density Q is equal to lambda L. Substitute here lambda L by epsilon naught. LA cancel, then you will get electric field E is equal to, here, sorry, pi R, 2 pi R into L. Curved surface area is equal to 2 pi r into L, base perimeter into height. So answer is electric field E is equal to lambda divided by 2 pi epsilon naught r. Electric field E is equal to lambda divided by 2 pi epsilon naught r. Okay, so electric field for a long, infinitely long charging conductor is equal to lambda divided by 2 pi epsilon naught into r. Or മേലെ താഴെ 2 multiply பண்ண கொஞ்சம் கூட simple ആയിട്ട് think ചെയ്യാം. That is 2 into 2 4 1 by 4 pi epsilon naught ആവും. So k into മേലെ ഒരു 2 multiply பண்ணி അപ്പൊ k into 2 lambda by r എന്നും we can study. Okay, അപ്പൊ k into 2 lambda by r or 1 lambda by 2 epsilon naught into r. This is the electric field due to infinitely long conductor. But for infinitely long conductor, electric field E is equal to lambda by 2 epsilon naught into r. This is the electric field due to infinitely long conductor. Next one is electric field due to an infinitely large plane sheet of charge density sigma. Here a large plane sheet, infinitely large plane sheet. So I consider a Gaussian surface. In the Gaussian surface, we want to consider large surface, but other infinitely large plane sheet. So we consider a cylindrical surface there. We consider a cylindrical surface, Gaussian surface there. What is the direction of electric field? This is positive charge. Electric field is always away from positive charge. This cylindrical surface has two surfaces. That is, one is base, this is, another one is curved surface. Then what is a total surface? Then what is a total electric flux? Total electric flux is integral E dot ds due to curved surface plus integral E dot ds due to base. Here for this plane sheet with a positive charge, electric field is always away from that positive charge. I consider a Gaussian surface. These two surfaces are there. One is base, another is curved surface. But base is at an angle. Electric field on the direction, ds on the direction, because perpendicular to surface. This perpendicular to surface on the direction. E and ds are 0 degree. E and this ds are 90 degree. That is, EDS, angle between E and ds for base surface is 0 degree. Curved surface is 90 degree. Already there is 90 degree angle, cos 90, 0. So this becomes 0. E dot ds for curved surface is 0. So there is two base surfaces are there. That is q by epsilon. Q by epsilon. We get two base surfaces. Two base surfaces are considered. So two base surfaces are two curved surfaces perpendicular. Electric field ange ds ange 0 I perpendicular. So cos 90 becomes 0. ds ange und inge und. So 2e into integral ds. What is surface area? Curved surface base surface area. Base surface area that is pi r square. Base surface area that is pi r square. Okay. So pi r square is the area, that is 2e into pi into that distance. Direct substitute pannam. A direct substitute pannam. Area is a. So 2e into a. Okay, but 2 into E into integral ds is total area, so that is A. That is equal to Q by epsilon naught. What is Q? Q is surface charge density. What is surface charge density? Surface charge density is charge by unit area is such a surface charge density sigma. Then Q is equal to sigma A. Then Q is equal to sigma A. You can consider Q is equal to sigma A here. So sigma A by epsilon naught. A cancel. Then electric field is equal to sigma by 2 epsilon naught. So electric field due to a charged infinitely large sheet is equal to sigma by 2 epsilon naught. Here we studied some application of Gauss's theorem. That is not only for Not all for this derivation, understand how apply Gauss's theorem. Here we want to understand how apply Gauss's theorem. That is for studying this, understanding these derivations. Okay, for understanding how apply Gauss's theorem. What is Gauss's theorem? Total electric flux is equal to Q by epsilon naught. In the equation on all derivation we are applied. So understand how apply Gauss's theorem. Total electric flux is equal to Q by epsilon naught. Okay, electric field E is equal to Q by 2 epsilon naught. That is electric field due to this electric field due to a infinitely long plate. Okay, next, before that, next we want to understand two parallel plates. If there are two parallel plates, what is the electric field? Two parallel plates are there, then how find the electric field? Here, two parallel plates are there. Here, sigma by 2 epsilon naught is the electric field. So, I consider a positive charge here. Here is also a positive charge, two positively charged parallel plates. Okay, due to this positive charge, away from positive charge, in the side consider away from positive charge, in the direction sigma by 2 epsilon naught is the electric field. That here, due to positive charge, one side sigma by 2 epsilon naught, other side also sigma by 2 epsilon naught. Here also, in the plane, in the side, in the sigma by 2 epsilon naught. Then my question, what is the electric field inside two parallel plates? Electric field inside two parallel plates is sigma by 2 epsilon naught plus sigma by 2 epsilon naught. That is 2 sigma by 2 epsilon naught. That is sigma by epsilon naught. The electric field inside two parallel plate is sigma by epsilon naught. Okay. Now last here electric field due to parallel plate is sigma by 2 epsilon naught. So electric field inside a parallel plate is sigma by epsilon naught. Okay. But these are the applications of Gauss's theorem. What is Gauss's theorem? Total electric flux over a closed surface is equal to net 1 by epsilon naught times net charge enclosed. Always what is total electric flux? Total electric flux. Okay, if you consider a spherical shape, say spherical shape, what is electric flux? Electric flux entering your electric, if you consider a spherical shape consider paniyal, into the spherical shape some electric flux are entering, away from the spherical shape some electric flux are leaving. Question here, what is the total electric flux for that spherical shape when electric field entering and leaving are there, or if it is placed in a electric field will place paniyal, what is the total electric flux? Answer 0, because they are enter and leaving. Enter pannumbol or electric flux irukku, leave pannumbol electric flux irukku, both are in opposite because entering and leaving one positive and other is negative. So answer become 0. Okay, for a spherical shape or a cube shape, in the mari shape here enter panna electric flux leave panna electric flux total become 0. So total electric flux become 0. Think panna. Okay, but these are the Gauss's theorem and its application. Okay, so in the chapter we discuss about first electric charges, then electric charges in force is produced, that is Coulomb's law, and electrostatic force, then electric fields at different points, then last Gauss's theorem. Okay, but these are the basics in this chapter. In the chapter, the basics is the Mariana. About here, we want to study how apply these equations and this concept in problems. So we want to discuss some more complicated or advanced level problems and simple problems and advanced level problems. Advanced level is no more than large advanced level, that for NEET level tough questions. Okay, and the questions discuss in live session. This is the basic concept of this chapter. Okay, but study well and try maximum questions. Okay, bye.